So, r is the position vector, f is the force vector, and theta is the angle that separates both vectors. So here we have that F is equal to 188.45 pounds, and in order to get the total torque on the structure, we need to add up the torque made by this force minus the torque made by gravity. The torque made by gravity is calculated with the center of mass here. We will take this as R, which is 3 inches, and the force will be the weight of the structure. So we see that the force acting on the structure by gravity is at 135 degrees. So after the calculations with this formula, we get that the torque made by gravity is 228.95 pounds-inches. Okay, so in order to start moving, the piston must exert a torque on the structure equal to this one. So we equal them. So now the torque made by the force of the piston is equal to 228.95 pounds-inches. So we know F, and now we're going to isolate the variable. So here we have the relationship between R and theta. We know that this structure is at an angle of 90 degrees. So we can make a right triangle. So R is going to be the cosine of the angle, this angle here, times the length of the piston, which is 10 inches. So we have now two functions. Here is one and here is the other. So now we are going to isolate the variable. Here is isolated. So we are going to substitute this into this equation. So we get, instead of R, we're going to get 10 times cosine of theta times the sine of theta equals 1.23146. So this will be the function of theta. With this, I will then take the derivative with respect to x of this function, which, applying the product rule, which says I will take this as u and this is v. So the product rule says u prime v plus uv prime. So here, u prime is going to be cosine. Cosine, the derivative of cosine is minus sine, times v is going to be minus sine squared. So we have minus sine squared here. Then u is going to be cosine of theta, and v prime is going to be the derivative of sine, which is cosine. So we're going to have cosine times cosine equals cosine squared of theta. And then the derivative of this side is going to be 0, because this is a constant, and then we have 0. So now, with trigonometrical identities of sine squared of theta plus cosine squared of theta equals 1, I can substitute sine squared of theta with this. So I'm going to substitute this in here. So now I have cosine squared of theta minus 1 plus cosine squared of theta equals 0. So, adding this up and passing the ones to the other side, we have 2 cosine squared of theta equals 1. So, then I get the value of theta here, which is cosine squared of theta equals 1/2. Then we take the square root of that. So the square root of 1 is 1, and we have square root of 2 under it. So we then rationalize, and then we get a square root of 2 over 2. So in order to get, this is equal cosine of theta. In order to get theta, we need to apply the inverse function, which is arc cosine. So we take arc cosine of this side, we need theta alone, and then we take arc cosine of this. This one is going to be the cosine of 45 degrees, so theta is going to be 45 degrees. So after having that answer, we're going to substitute that value in this one. We're going to solve for r, which is here. R equals 1.2146 over sine of 45 degrees. Then we substitute the values, and the final answer for r is 1.717. This is, with these values, we're going to get the torque necessary in order for it to move.